right, let's get our key points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. In our original function, so sine of x, we have 0, 1, 0, -1, and 0. Let's do our transformations. So we go, not left, don't know why I put that. We go right, pi over 4, and down 2. So this affects the x, this affects the y. So our new x, we're just going to add pi over 4 each time. So pi over 4. I'm going to, before I do all that, make this all have a denominator of 4. That way, when I do my math, I don't have to worry about it each time. I'm going to add pi over 4 each time. So I'm going to get 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4. And then the y's have shifted down 2. So down 2. 1 minus 2 is -1. Down 2. -1 minus 2 is -3. And 0 down 2. Now, all we did was shift down 2 from the x-axis, but those zeros from here are still going to be undefined for the cosecant, because this is still inside of x. So, still going to be the vertical asymptotes. So now, if I go to graph it, I'm going to graph it. Let's see. Let's do it with pi, so 1 pi over 4. Because I don't have enough room, I'm just going to label it with fractions. So 1 pi over 4, 2 pi over 4, 3 over 4, 4 over 4, 5, 6, 7, 8, 9. They all have pi over 4s. So my vertical asymptotes are at pi over 4, 5 pi over 4, and 9 pi over 4. There were no reflections or anything, but we did shift down 2. So 3 pi over 4, we're at -1. And then at 7 pi over 4, we're at -3. And I'm out of room. And that's okay. So there's no reflections. And that's what we look like. Kind of cool. Alright. Now we're going to do one with a bunch of stuff to it. And this one was giving me the hardest time. So, let's start with our key points. So, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now we can do all the transformations. Let's see, our guide function is cosine. So 1, 0, -1, 0, 1. Alright, so now let's look at some different transformations. So, on my x value here, that's a stretch or compression, and it's always by the reciprocal of it. So I'm going to take all of the x coordinates and multiply it by 3/8. All right. So 0 times 3/8 is still 0. This one becomes 3 pi over 16. 3 pi over 8, 9 pi over 16, and 6 pi over 8. But then we also have a shift here of left pi. So I'm going to subtract pi from each one. And just to keep it all the same denominator, let's make that a 6 pi over 16 and make this one a 12 pi over 16. Just so that when I subtract pi, I can just subtract 16 over 16 from each one. So I'll eventually reduce it anyway, because minusing pi is 0 minus pi is just negative pi. 3 pi over 16 minus 16 pi over 16 is negative 13 pi over 16. Negative 10 pi over 16. 9 minus 16 was it negative 7 pi over 16, and then negative 4 pi over 16. And then we can reduce some things here in a minute. Another thing to note is another way we could do it is we could find our period. So the period is 2 pi over b, which is 8/3, which is really 2 pi times 3 over 8, which gives me 6 pi over 8, which is 3 pi over 2. And then if I divided it by 4, so same thing as multiplying by 1/4, that's 3/8 pi. So I could start from my my shift. So I could start at negative pi and then be adding each time to get what I need, which is kind of cool. And that actually should be a 4, which makes that a 16, which makes the math. Because notice how I'm just adding 3 each time. So works either way. We can start from the same original points, do the transformations, or start from the shift and then apply from there. But yeah, okay. Now the change in the y values, we stretch by 2. So 2, 0, negative 2, 0, and 2. And then we shift up 1. So 3, 1, negative 1, up 1, and up 1. And then our zeros are still the vertical asymptotes. So I'm out of room here to graph, but, oh, and I'm actually in the very negative side, doesn't matter. Let's see, I don't really want to make 16 tick marks, but I can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'll do my vertical asymptotes. So negative 13, so 16, 15, 14, 13, and 7. 1, 13, 12, 11, 10, 9, 8, 7. So negative pi is at 3. 10, so 16, 15, 14, 13, 12, 11, 10 is at negative 1. And then the other one, 4, 1, 2, 3, 4 is at 3. We didn't have any reflections or anything. So like that. Let's do a cotangent one, because I haven't done one of those yet. Works the same way. So cotangent of 2x minus 3 pi over 2 minus 3. All right, so let's start with those key points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, I guess really we only need up through pi because the period is through pi, not 2 pi. But that's okay. We can do it all. All right. So let's fill it out for tangent. So 0, 1 over 0, which is undefined. 0, negative 1 over 0, which is undefined, and 0. All right, so let's figure out what transformations we have. So I have a 2 with the x. So the 2 with the x tells us there's a horizontal compression by 1/2. This negative 3 pi over 2 tells me we went right 3 pi over 2. And then that negative 3 tells me we went down 3. All right, since there's really only one vertical change, we can go ahead and get that new change. So, down 3. Still going to be undefined. Down 3, undefined. Down 3. All right, let's do some x changes. All right, we are going to apply this first. So that's still going to be 0. If I multiply that by 1/2, it's going to become a 4. It's going to become pi over 2. It's going to become over 4. And if I divide that by 2, it's just going to leave pi. I'll rewrite that, and I'll rewrite that. Now, I should have done it in 2s. To go to the right, I'm going to add 3 pi over 2. You know what? I'll either add 3 pi over 2 for the ones that have 2 as the denominator, or 6 pi over 4 for the ones that have 4 as the denominator. So, and I'll do it even in a different color, so that we have our final one. So 3 pi over 2, 7 pi over 4, this is over 2, so pi over 2, and 3 pi over 2 makes 4 pi over 2, add 6, that makes 9 pi over 4, and this one doesn't have either. Let's make it a 2, because why not? So 2 over 2. So 5 pi over 2. Okay, now let's try and graph them. Oh, I almost hit erase all. That would have been crazy. Okay. I should make them all in 4s. Dang. Okay. Let's see. So 6 pi over 4, 7. Let's see. 8 pi over 4, already over 4, and 10 pi over 4. So 6, 7, 8, 9, 10. So we'll just go to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are undefined at 7 pi over 4. So 1, 2, 3, 4, 5, 6, 7. And at 9. And I feel like a lot more in between. That's not right where I wanted it. At 6 pi over 4, so 1, 2, 3, 4, 5, 6. We're at -3. At 8, we're at -3. And at 10, we're at -3. Ah! Should be down lower, but it's right where our buttons are. And our cotangent function looks like this. So it looks something like that, something like that, something like that. And then we can continue it on. So there's definitely more points, but that is good enough. All right.